right, here are 5 quick problems with simplifying imaginary and complex numbers. So the first one, simplify the square root of negative 81. Remember that we can think of that as the square root of 81 times the square root of negative 1. We know the square root of 81 is 9. The square root of negative 1, we learned, is equal to I. So that would put that I right there, and we get an answer of 9I. A reminder here that there is no positive or negative, because when we're just simplifying, we're assuming we are already working only with the positive radical square root of negative 81. So that's how we get our answer of 9I. Solving, however, once we move 16 over to the other side by subtracting 16 on both sides, when we square root, we do introduce both a positive square root and a negative square root. So we know that x could be the positive square root of negative 16, aka 4i, or x could equal the negative square root of negative 16, or negative 4i. So that is where you get two answers when you are solving and introduce both positive and negative square roots. In number 3, 4, and 5, it's important to remember that we can simplify these just like we would if they were expressions with the variable x or y. But one big important note, other than the fact that I is equal to the square root of negative 1, is that I squared is equal to negative 1. We'll use both of these concepts quite a bit in working with imaginary and complex numbers. So number 3, 8 times 4 is 32. I times I is I squared. We're left with 32I squared, but we know I squared is equal to negative 1. So this is really asking you what's 32 times negative 1. So we get an answer of negative 32. Number 4, in simplifying here, think of this negative as a negative 1 out in front of that set of parentheses, so that will need to be distributed there. So we're looking at 3 plus 7i minus 2 minus 12i. Now you're just adding and subtracting like terms. 3 minus 2 is 1, and we've got a positive 7i and a negative 12i for a minus 5i. This is our final answer. Note that you can't subtract those and get like negative 4i or something like that. There's no I squared here because we're just adding and subtracting like terms, so we don't introduce any kind of exponents. All right, and number 5, last one here, distribute our 6i. 6i times 4 is 24i, plus 6i times 2i is 12i squared. We know that's not quite good enough because of that I squared equaling negative 1. So now we're looking at 24i plus 12 times negative 1, or 24i minus 12. You can also think of that as negative 12 plus 24i if you're wanting to write that real number first, followed by the imaginary number. It's just a quick little review of 5 problems there. Yeah.